So I opened that EIP proposal 2 weeks ago, and there was not much discussion happening on a Gitter. The one response I got that we need to construct like a really good scheme of how this Genesis format should look like. This is actually might be a lot of work because of all of this communication issues between client developers.
Yeah, so I weighed in on this in Gitter, and I don't think it's a ton of work, and I don't think the problem isn't necessarily the communication problems between implementers. It's more we need to agree on like a driver for this project. So if you told me right now, hey, Frederick, you're responsible for this, I take it on and I'll try to come up with a proposal for a schema, and it'd take me a couple of days or a week or something. But I think we need that driver. Otherwise, it's just not going to happen because like there's a lot of differences between the different formats, and you kind of need to actually dig in and understand all those differences.
So basically, we need to dedicate a person to work just on that issue.
And I don't think it would be a ton of work. Like I'm imagining like a week of work or something.
Yeah, I also weighed in on that, and I totally agree that we need a schema, because otherwise we'll again wind up in the case where we have some kind of non-formal description and different implementers implement it in different ways, and then the consequence being that 5 months down the road there's a mismatch, and there needs to be a lot of coordination again to resolve how does blah 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 implementation differences. So it will be a lot simpler if we have a proper schema, a proper definition.
And so basically we need a JSON scheme with a full description of every field, field name and field value, what kind of value could it take, and what is the meaning of that field.
I could help with the JSON schema if needed, because I just wrote a bunch for some of the other test set types with the schema part, that is.
Who is talking now?
Sorry, this is Everett.
Everett. All right.
Just in the last couple of days, I've been making some PRs into the test repo.
Yeah, that would be awesome if you
So should I just go with what's on the pull request now, make a schema for that, and I mean what's on the 1085, the issue 1085 right now, the common Genesis format one?
Yes, that sounds good to me. And there are some other, more fork blocks that need to be added, and there are a few features that Parity uses that might make sense to have in there. Things like max code size, which I don't think any other client has implemented in the Genesis. So I don't know how to do it.
Some things like code size are hard-coded into forks. So basically when you say that the Byzantine fork block is this number, after that number all of the rules agreed with Byzantine are applied, and these things like code size are also applied with that fork values.
Okay, well, I'll just go with what's there now and make a schema like that, and then it can be modified as we go. But if we just start enforcing it for CI and then we realize it's not flexible enough, then people will be forced to change it when needed. Does that make sense?
Yeah, so open a pull request is at least beginning, starting doing this schema, and then have a discussion, but more active.
Sounds good.
Yeah, whom could I talk about this issue?
What issue?
I mean,
schema or
designing the scheme, yes. I
So
want
if
direct
Everett
contact.
gives it starts it up, then we can iterate over it on the Gitter channel like we did last week or whatever it was.
So I don't know. I'll make the schema and the pull request, and then I guess let me know. Just let me know what to do from there.
Cool. Sounds good. Sounds like the next steps are pretty clear here. Any final thoughts on EIP 1085? Yeah.
I have a call. I had a call, and on that call we discussed how could existing project Thunder, I guess Thunder, to use our existing blockchain tests. And I actually thought about that. Maybe some people trying to use Ethereum in the private chain. They use it's slightly different gas prices and stuff. And would it be possible to also encode those gas prices for opcodes into the Genesis format of some? Maybe we could think of a mechanism to do that. Because if we manage to do things like that, we could use existing blockchain tests for other Ethereum implementations. So the question is, could gas prices for opcodes be also included in Genesis format somehow? That's a good idea.
That we would prefer not to implement that for gas, because I think the compiler can optimize better if it's constants.
So
it would come at a price, I guess.
So I guess I wouldn't argue for that, but I would also argue for maybe a slightly different approach to testing, which would be every client fills the tests and then you compare the resulting JSON. So in that case, you wouldn't even have the gas price in the, because right now what we do is we have CPP Ethereum fill the tests, and then the other clients run the tests instead. And there's no reason we can't just have, every client fill the tests instead, other than, all the engineering work it's going to take to make that happen. Every client fill the tests and then report the resulting JSON, then compare directly the JSON. And then that frees, that really makes it a consensus test set instead of a do I conform to CPP Ethereum test set.
No, not really. You don't have to fill the test. Once the test is created, there is no need to refill it actually. Any client could just run it. It's more safe, because when you regenerate the tests, you might change something you even don't notice. But once you fill the test, you have like a set of instruction and the result, and every client could check that same instructions.
Still store a record for every client what the filled, and that's what would happen for CPP Ethereum. It's just that instead of storing things like the final gas and the final balances of accounts, you just wouldn't store those. You would only make assertions in the expect section about the storage, and then the final gas and stuff like that, you would just look at the filled version of the test. And then you'd be, I don't know. I also like that it would give you more fine-grained assertions, because you might have, because right now it seems that a lot of it is done based on, hashing the resulting state and then comparing hashes. And
not really. A blockchain test has a set of blocks and the result post state. This is the main type of test for the clients. So basically it repeats the procedure of importing blocks and just comparing the post state after importing all of the blocks. It's not about hashes. And about filling, it would be a good if other clients could do the test filling process. But other client devs, they don't have to create their own test tool, which reads the test filler and create a final test. All we need is to come.
That's not that big of a leap from having a tool that reads the filled tests. Honestly, like you read the JSON, you figure out which parts of the pre-state, you run those to set up your client, and then you run the code and then you
So
check against
actually,
post state. Here you just drop the checking against the post state part and just generate the post state.
This whole issue about Genesis format is because I wanted other clients to be able to generate the tests themselves. But to do that, I have to have those RPC methods on which I transfer the instruction how the chain should be initialized, because test has different chain options at the beginning. So basically, I'm trying to pass the blockchain test information through RPC methods.
I don't know. That sounds like more implementation effort by. I mean, now they have to pull in an RPC library that can speak your protocol.
Yeah.
Instead of them just having their own way of invoking their program on the command line.
Well, they could read those tests from JSON themselves if they want, but the RPC method, those RPC.
You could still read them just straight from the JSON you just said?
I mean, that common Genesis is a first step. If there will be a RPC method with this common Genesis format, then I could initialize any client of Ethereum to run this specific set of...
That speaks your RPC specifically.
Well, all clients speak RPC. I think it's a pretty nice way.
My client does not speak the RPC, but
clients should speak RPC. It's like negotiation protocol. So then by using those RPC methods, I could tell the client to run the test or generate the test, whatever. It's just, it would be a series of methods for exporting and importing blocks and transactions. Running those tests would be possible.
Okay, well, I'll make a schema for it and then we'll, I guess we'll see where it goes from there.
Thanks, guys. Dimitri, any final updates on testing stuff other than this particular question?
So I started working on blockchain test over RPC, and I plan to ask for some changes and on Ethereum get block by hash method. I need block signature and transaction signature as a field nonce and mix hash for block and signature fields for transactions. Because currently I see that those methods exporting transactions without those signatures.
Is there any question or action item for the core devs, Dimitri, about that? Or is that just a FYI?
Yeah, I want to solve issues one by one. So the first issue is to come to this Genesis standard. And after that, I think I will focus on other issues. I'm just talking ahead.
Great, thank you very much. That's helpful. Okay, let's go on to client updates. Hudson suggested moving these to the beginning of the call because the calls have been getting longer and we don't want to miss them. So let's start with Parity.
No real update from us, I think. There hasn't been any major release. We have a Casper testnet in the works. Like not a permanent testnet, just something to play around with and test our transaction pool and networking code. So if you're interested in checking that out, reach out to us.
Thanks, Fred. Cool. Geth?
Yeah, I think Peter couldn't make it, so I'll take this. So our latest two releases, I think they mainly fixed some issues around transaction, where we had first memory bloat, and then we had races, which made the client lock up. We're doing some interesting work. Actually, Peter is regarding his memory pruning we do of the state, and he's implemented a streaming memory pruner which performs a lot better. That is really tangential to some other work he's doing, which I mentioned 2 weeks ago, about a new model for fast sync, a new protocol, which he is experimenting with, and we have high hopes for that. And yeah, we're hoping that within the next month or so, make some really good progress with how Geth performs. That's about it. Cheers.
Thank you, Martin. Do we have anyone here to speak about CPP Ethereum? It looks like we don't have Pavel with us. Okay, we'll move on. Harmony?
We have prepared the release candidate version and now working on polishing, test runs, and fixing some stuff. So we're about to release in a week or so. This release is about performance. We have tuned RocksDB. Now it reads faster from 5 to 10 times. And another thing is stability, because we had to protect from Eclipse attacks because they are happening on the main network. And we also have reduced the memory footprint. So this version is more stable than previous one and is able to run on the main network without any tricky stuff like restarts or something like that. So yeah, it's pretty stable.
Mikael, have you seen an evidence of Eclipse attacks happening on the main network?
Yeah, it's like, you know, Martin, we hadn't been protected from many connections with the same IP address, and there are some addresses that it's like, you know, a lot of such addresses, like maybe about 10 or 20, maybe 50 addresses I have noticed that does a lot of connections from different ports, and they just do nothing, no handshake. So this is just like, looks like an Eclipse attack. The primitive Eclipse attack we hadn't been protected from, so now we are. And
yeah, very interesting. You're more than welcome to send me any information you have about that.
oh, okay, I will.
Curious.
Okay, we'll try to find those logs with these connections. So yeah, and I will describe your details of attackers' behavior. And there were also attacks like, you know, with the malformed RLP. And yeah, we didn't count how many bytes in RLP before allocating a memory. Like there could be a length of array with about gigabytes, like let's say 10 gigabytes. So we tried to allocate such big array before, understanding that RLP is much shorter. So this was another kind of attack. Like, yeah, but we had to protect it from that also. So attacks are constantly happening, and that's good that we were not protected, because we can notice that they are happening.
Thanks, Mikhail. Do we have anyone from Pegasus today? Okay, we'll keep moving. Trinity?
I'm not from Trinity, but I know they released an alpha, which is super exciting, and I know they're focused on performance, primarily on performance, and some kind of intermittent bugs that might cause their system to crash. But I know they're working very hard and making super significant progress. I expect them to have some nodes syncing to the mainnet, like being participants in the mainnet.
Thanks, Danny. I saw the announcement about the alpha as well. Also very excited. So if Piper and team are listening, congrats, guys. Great news. Ethereum, this was brought up on the last call. Okay. Do we have anyone from Nimbus?
Yeah, I'm around, Jacek from Status. So I can give a quick update of what we've been up to. We've been experiencing both the pleasures and the pain of working with a less known language. The pain being obviously that we have to develop a lot of base components like big integer support, cryptography. We're working on networking, making sure that that's solid, all those things. The pleasure being obviously the enthusiastic support we've had from the NIM community. So we managed to produce a number of libraries that supply these base components for anybody that wants to write like a crypto client. As far as progress on Ethereum goes, we're putting things together. We're working on the EVM. Very much appreciating the test suits available. We're working on the Dev P2P framework and sort of starting to implement the wire protocol to enable us to start syncing the chain, well, soon. So yeah, lots of good work there. Looking forward to getting an executable together that can actually do things.
Thank you for the update, Jacek. Okay, did I miss any clients? Okay, let's go to research updates.
I think I'm the only one here. On the Casper side of things, as the clients have begun implementing EIP 1011, we've been kind of iterating and working through some of the finer details, mainly around executing transactions in parallel and kind of handling the vote transaction queue, things around that. We're on the development side, we're opening up some more helper functions from the contract that allow the clients to get some more information. But generally, Parity's done some great work. I know there's some work kind of going on with the side team. Geth, we're going to begin working on the implementation of IEVM. I know Harmony has previously had an implementation. They're probably not too far off. Just kind of putting all the pieces together. Hopefully getting a test net with more than just Parity up in the next few weeks.
Thanks, Danny. That's really exciting.
Yeah, as for sharding stuff, Justin, Drake, and Vitalik have a series of posts around signatures and beacons on ETH research. Some kind of exciting new developments there that are going to allow some really interesting scaling stuff and the sharding stuff. So if y'all are interested in that, check out ETH research.
Awesome. Great. Thank you for the update. Okay, let's do Ewasm. Axic and friends, does one of you guys want to give an update from the Ewasm team?
Can you hear me?
Yes.
The update would be that we are working on finalizing the needs for a public testnet, and we are shifting focus from one part of the project, which is called EVM to Wasm, to other parts more important for a testnet. I think that would be the quickest update we could do.
Are you planning on starting a new testnet for this, or like making one of them Ewasm?
No, it would be a brand new testnet, and it would have both EVM and Ewasm enablement. Changing any of the existing testnets would mean to update all the clients. And right now, so for example, we could change, I guess, Rapston or Rinkeby, and those are mostly run by Go Ethereum. And that would mean we would need to support Ewasm and Go Ethereum, which isn't the case at this moment yet. So this new testnet would be run with CPP Ethereum. And hopefully shortly after that, it may be joined by Go Ethereum's Ewasm implementation, but we have no ETA on that yet.
Cool, sounds good. Keep me up to date, because like if you do start one parity, like it would be interesting to see what it would take to for parity to join that testnet as well.
Sure, that sounds good. Thank you.
I've seen in some of the Ewasm channels, and I haven't done any research, but the EVM to Ewasm, is that some sort of tool that transpiles bytecode, or what is that?
Yeah, it is. Is it a tool which can be fed with EVM bytecode, and it would output an Ewasm bytecode?
Well, it does a bit more than that.
Is that in an attempt to eventually just be able to port the entire EVM over to Ewasm? Like
So
contracts or what?
Yeah, I mean, this tool could have several use cases. One of the use cases we have been using it for is to use the Ethereum current state tests on an Ewasm implementation. Future use case could also be if someone implements a client from scratch and they make it a native Ewasm client, they wouldn't have the need to write an EVM implementation. They could just use this tool to translate contracts before execution.
Gotcha. Cool.
So it's quite a big project, and it is passing quite a few tests at the moment. It actually has been written probably 2 years ago, and at that point it was like 90% passing the frontier tests. But since frontier, we did have moved on quite a bit. And right now, it isn't passing everything in Byzantium, but the plan is to finish it to a certain level, open it up to the public, give some guidance on how to use it and how to fix some of the remaining state tests. And maybe the hope would be that we could get the community more involved in finishing those.
Question on that point you made about using an Ewasm first approach and then translating all the old existing EVM code to Ewasm in your new fresh client. Like, what kind of issues would you expect trying to do that? I mean, let's assume that we're a new client, which we are, and we don't have an EVM, which we kind of don't. If we wanted to go Ewasm only, what would you be looking out for in terms of problems that could lead to?
Well, I guess the only real problem right now would be this EVM to Wasm tool isn't fully finished yet. So you cannot just outright use it and run every single contract you would want to run. It can run a subset of contracts, and we do plan to finish it to a level where it would run some common patterns of contracts, but definitely it would be missing out on some other edge cases. So I guess that's the main limitation at the moment. There's a lot of help needed in finishing that up. Otherwise, I don't really see any major issues blocking this kind of design.
What about security concerns or gas cost concerns or anything like that, like attack vectors that open up that weren't possible before?
So this compiler would be kind of like an ahead of time EVM to, say, x86 compiler. It would be pretty much the same concept. It does, so the output itself, what it generates would be following as of today at least, it would be following the gas cost 100% how it works in EVM. And this EVM to Wasm tool itself should be compiled into Wasm and should be metered. So when you execute it, you would have a an actual upper bound of how much time it should take to do the translation.
Cool. Yeah, that's really interesting. Thanks for the update.
Thanks.
Thank you, Alex.
Alex, is EVM to C compiler still just a fairly sort of straightforward translation attempt to generate very high quality Wasm code out of, for instance, taking every opportunity to use 32 or 64-bit registers rather than using the library or not high precision, but
Greg, can you repeat that? Did you ask?
I'm asking whether EVM to Wasm intends to be an optimizing compiler that can take the encode down to 32 and 64-bit registers. It's going to keep on doing everything with a multi-precision library.
It does everything as the current EVM requires. So it does operate on 256-bit stack items. But it should be possible to...
So the optimization gets pushed down to the Wasm compiler.
Yeah, no optimizations happening in EVM to Wasm.
I mean, it's open to have optimizations. And it should be possible to implement EVM 1.5 and the SIMD extensions as well.
Yeah, I'm sort of looking, I don't know if it's important, but nobody's funding 1.5. So.
So just one last remark on that, Craig. Actually, it should be possible to, say, support EVM 1.5 with the SIMD extensions, and if it would detect EVM input as such, it could make a decision to optimize the entire output to 64 bits. That might be an interesting idea to explore in the future.
Yeah. If the library, we can get into this later. It could be done at either end. Yeah. It might be easier at the first end when it's still clear what the Wasm structure is. Into the details. No need.
Thank you for the update, Alex. Greg, just a heads up that we're having a little bit of trouble hearing you. I'm getting about 2/3 to 3/4 of what you're saying. Yeah, it's a little distorted, so I don't know if there's any different place you can stand and maybe get better connection or something, but just as a quick heads up about that. Let's move.
I'm up in the mountains with AT&T hates me. I'll talk louder.
Thanks, Greg. I'm sure it's very beautiful there. Cool. Okay, let's move.
Yes, but the cell service is lousy.
Sure. Let's move to the first item on the agenda after the client and research updates. That is EIP 1087, which is net gas metering for S-Store operations. This is Nick Johnson's EIP.
Is Nick present? I think not.
I think not as well. Does anybody else want to sort of champion this or speak to this? Okay, we'll table that and keep moving. All right, back to Wasm. The next topic here was some concerns expressed by Greg that using native browser VMs for running Ewasm is not DOS hardened. Greg, do you want to kind of kick off by expressing some of your concerns here?
The basic principle is simply that if you can cause a JIT to do more work than what is being paid in gas, then you've got a service. And there's a number of ways to make that happen. You make the compiler go exponential. You can cause the cache to become useless or worse. You can cause it to think that things are hot and compile stay hot. And any other number of clever things you might do. And pass it to KC. I put a link into it, but it was pretty late. So Casey can summarize what he's doing. Casey, are you there?
Yeah, can you guys hear me?
Loud and clear, Casey.
Is it too loud?
You're
Perfect.
No.
Yeah, so I opened a
control.
Okay, so yeah, Greg has been reminding the Ewasm team continually. We've sort of been saying we'll cross that bridge when we get there, and been focused on building the interpreter. So I opened a pull request on the Ewasm design repo with an overview of how we understand the JIT compilation issues. Basically, there's two ways to execute Wasm code: interpreted or compiled. And well, I mean, Everett's here, he's on the call, and he says that there's literally no difference between interpreted execution and compiled execution. Paul points out that, yeah, that is technically true, except for the 2 orders of magnitude, and execution speed is the only difference. And the reason it's important is because if we're going to allow one use case for switching from EVM to Ewasm is to sort of be the precompile that ends all precompiles. So it allow users to deploy their own precompiles, but that will only work if the Ewasm gas costs are calibrated to native execution speed, not to interpreter speeds, because the benchmark we did was using the EC pairing precompile, and when running an interpreter, it takes 21 seconds to do 3 calls, but when run with a JIT compiler, it takes 100 milliseconds. So it's over 2 orders of magnitude difference. But we didn't know, we were kind of hoping optimistically that V8, for instance, the Wasm JIT engine in Chrome and in Node.js, because the validation pass over Wasm code is linear, we were smoking some hopium that maybe the JIT would also be linear, have a linear time upper bound. So finally, a couple weeks ago,
again.
So a couple weeks ago, when we tried to reach out and ask various JIT compiler experts, and none of them could really nobody could give a confident answer on whether or not there would be a denial of service attack, as Greg suspected there would be. So finally, a couple of weeks ago, Guido Veronkin hooked up a fuzz tester to V8 and found some compiler bombs. They're 20 kilobyte pieces of WebAssembly code, which is even smaller than the current size. I mean, the current maximum contract size you can deploy on the mainnet for EVM is like 32 kilobytes. So these Wasm, these pieces of Wasm code are even it's even smaller than that, and took about 2 seconds to instantiate or compile in V8. And they're kind of funny to look at because you can see the like the highly nested loops and different features that might be tripping up the JIT compiler. So yeah, Greg, you were right, and so now we know for sure it's a problem, and we're at the phase where we're thinking about potential solutions or approaches to solutions. And besides using a JIT, the other solution that's often discussed is using AOT, ahead of time compilation. And I've been skeptical of that because to me, AOT sounds like a big PITA with a lot of plumbing. And I mean, you can imagine how it might work where there's a directory of cached.exe files. So every contract, when it gets deployed, the Wasm code gets compiled ahead of time to a .exe file. And so the client, instead of maintaining a state tree of where it pulls EVM bytecode and interprets it, it maintains a cache directory of .exe files, one for each contract that it executes when each contract is called. And it sounded really difficult to me, but then Paul, who's also on the call, is Paul there?
I hope you can hear me. I hope I'm sitting next to Slane. I hope we don't have an echo. Yes.
Yep, you're coming in clear. Yeah, Paul explained I was able to explain to me how ahead of time might work, and I guess I'll just let him take over now.
Just to introduce myself, 10 seconds. I'm on a grant for the Ethereum Foundation working on PyWebAssembly. I am trained in mathematics, and I'm reading the WebAssembly specification, it's reporting typos, and so I'm not an expert on JITs and how things are implemented, but I know that to implement WebAssembly, there are a lot of things you have to do, and there could be a lot of things. I didn't hear Greg clearly. I think the question, so I don't know how to answer exactly to Greg's question, but I think the question to me was ahead of time. Yes. So we take LLVM, the compiler, and we compile it to WebAssembly. So so LLVM, so there's sort of a compiler compiling a compiler. So we compile LLVM to WebAssembly, we meter that, and then we use that metered LLVM toolchain to compile smart contracts to x86-64 and ARM binaries. And perhaps over time we will support different binaries. So that was the big idea. And we'll meter this compilation. So that's it for me. I hope that answers.
Yes. The issue is that Wasm set up so you can traverse it in linear time, which means it's possible to run through most of your optimizing compiler tricks in n-log n time. Typical compilers don't do that. They go ahead and go for the gold and are willing to go quadratic to get there. So it's possible to write a good Wasm compiler that stays n-log n. People aren't doing that because for web pages, it just isn't a requirement. If a web page goes wonky, the web itself does fine, and whoever's web page it is has to fix it. But when a contract goes wonky, it's a security hole. So I don't see any real answer except that somebody has to write bomb-proof Wasm compilers that we can run ahead of time. Now, in the C++ compiler, it's an almost trivial change in one file to move the spot where the code is compiled by the JIT to the spot where the code is first loaded, and to take the output of the compiler and stick it into the existing state database and pull it out and run it when needed. So it just doesn't seem like a big deal there. The big deal is getting our hands on a bomb-proof Wasm compiler. And given that the foundation has a truly astounding amount of money at their public Ethereum address, I just don't see why financing that effort could be any kind of problem.
I respond. I know at least about a year ago, I don't know if it's still the case, but Firefox actually does have a one-pass, a single linear pass compiler to binary, from WebAssembly to binary. And in the background, it has the ion optimizing compiler. But perhaps if we can wrangle out the single pass Firefox to WebAssembly to binary compiler, we have what we want. And even if we still have the ion things going on in the background, that's still okay, I think, because we'll still keep executing the single pass version. So this might be a solution. Another solution, I might be interested in writing a binary WebAssembly to binary compiler. So there may be,
funding project.
You said that there's no solutions. These are two possible paths.
Exactly.
I can also chime in and say that Parity is working and has a great interest in writing one of these compilers. So, there's also that possibility. I'll also add that Greg, you were talking about compilers doing optimization work, and there's actually really good reason to not do that. And for the web, we can't expect that people writing programs like naturally optimize their end code, and a browser has a very legit reason to do all sorts of crazy optimizations on the Wasm level. I think we can push that to the users. So if you're writing a smart contract, and like if I'm writing it in Rust, I'd expect LLVM to output what is already optimized Wasm code, and the compiler from Wasm to binary doesn't actually have to do any optimization.
When you have a smart contract that's responsible for hundreds of millions or billions of dollars, and it's a tiny little piece of code, there is no excuse not to put absolutely huge amounts of work into it from every angle. So
I don't see how Wasm optimization makes that more secure, though. If anything, it makes it less secure to change around what the bytecode is.
Exactly. So you're right. Write incredibly efficient bytecode and look for something like an old-fashioned C compiler that does an almost one-to-one translation.
Yeah, that's what we would be looking at Parity if we're making a compiler for this.
And Wasm was designed to allow for fast streaming compilers. That's why the instructions are so very low level.
But then the question is, why are there vulnerabilities in the standard Wasm JIT engines? If Wasm was
because
designed...
they're trying to do a bunch of magic optimization stuff to make really low performance shitty code run faster.
Yeah, you're talking legacy graphics code.
I mean, what would be ideal from an Ethereum client developer perspective would be if these off-the-shelf engines came with a flag that said, do simple linear compilation and not fancy stuff that opens you up to JIT bombs.
As you know, I don't trust third-party code, and this just isn't that hard of a project. Find something open source or write it ourselves. See what Parity's got. I'd give Pavel 2 weeks if he had nothing else to do.
I also actually don't think it's that massive of a job. I think we could have multiple implementations of this in all the teams and not be too encumbered.
As someone who is writing, implementing the WebAssembly specification, it is a lot of details. So I think way more than 2 weeks.
Yeah, but Pavel's really good.
I also think more than 2 weeks, but I mean, we've written an interpreter, and I mean, that was not like a year project. It was a lot of work, but it's not something that is, considerably much more than writing an EVM interpreter, and compiler is a little bit different. But
yeah, I'm exaggerating, but it's just not that hard.
Well, how about compiling? How about doing something like compiling Wavm or LLVM to Wasm and then using it as a bomb sniffer? Would that take more or less than 2 weeks, or more like 2 wooks?
The bomb sniffer is the worst idea I've ever heard.
Why is that?
Because there's too many ways to slip code past the sniffer.
What ways are you thinking of?
Finding VMs that the sniffer doesn't do a good job on, like the next version of the VM you were sniffing, or an odd-off version you weren't aware that some client was using.
Well, then, I mean, if somebody implements a crappy EVM, Ethereum client on mainnet today, then it has DOS vulnerabilities. So I don't see how that's any worse than the present situation.
Oh, the present situation is probably much worse than we know. We're lucky a truly concerted group of hackers hasn't gone to take us down yet.
Can I add one thing? I think just the JIT bombs isn't the only concern. There are a lot of concerns with denial of service attacks. When you're implementing the specification, you can do it several different ways. Parts of the spec are left to the implementation. So just sort of this compilation time is one thing, but there are a list of other things that we should sort of...
Like what?
How the branching, the control flow is implemented, how to escape from a trap. I made a list actually of different concerns that I have that a lot of implementations deviate from the spec for optimization reasons, and so there might be asynchronous execution that would be sort of unusable for us. Resource exhaustion concerns that I have. non-deterministic behavior, all of these things. When we validate, the spec says that it should be validated at the very beginning when you're instantiating the module, but then a lot of implementations wait to validate functions until later, until right before they run. So I have a list of maybe perhaps 10 concerns that I have so far, and then a few others that I'm working on.
Oh, I saw that list, yeah.
Yes. And that's not to speak of hardware bugs. When we're so close to the hardware level, of course, there are hardware bugs. And if someone knows, you know, how it's going to compile, then they may trigger one of these bugs, and they might, you know, hack half of the network. So this would be a monumental devastation. So.
Will you be posting that list somewhere?
Oh, my GitHub username is POEMM, and it's one of my repositories, Wasm security concerns. Maybe I'll ask.
Just send me the link to it, I'll post it.
Lane will post it with the notes.
Thanks.
And the list is still growing, by the way.
I guess the question for me isn't how to make the most bomb-proof virtual machine in history, but what's the easiest path to enabling users to deploy their own precompiles?
Since nobody's answering, the easiest way is to use some off-the-shelf software. The safest way is maybe to inspect a single pass to, you know, compile JIT, or maybe ahead of time, and to check all of the different things in the spec, all of my concerns and other people's concerns, to make sure that to identify the attack factors, to tax it properly with gas. So I think you asked what's the easiest. The easiest is just to use off the shelf, but that might have security concerns.
Well, thanks, Paul.
Okay, let's keep moving. Thank you very much for the points, guys. Okay, so the next topic is Constantinople hard fork timing and what to include. This has come up on the past couple of calls. I think it was pushed from the last call again. Any further thoughts on timing and what should be included?
Is there a running list of EIPs that are potentially going to go in? There's no link on the...
Yeah, there are a couple. I can try to pull these out of the agenda from a couple of meetings ago. Sorry for not doing that ahead of time. I feel like block hash refactoring is one of them, and maybe a couple of others. Let me look.
Yeah, so shifting is in block hash refactoring. I think there's consensus about that. What else is there? So recently there's cropped up a few suggestions. There's a Skinny Create 2 by Vitalik, which is really nice in my personal opinion, because it allows you to do counterfactual contracts. Basically, you know where a contract will wind up based on an init code, because the address is derived from the init code. Then there is 3 that Nick has proposed very recently. The net gas metering. Yeah, well, these 3 we haven't really discussed on the core dev call. One other is Xcode hash, and there was one more. Are there any other which have been discussed for inclusion?
In the so there is a meta which is EIP 1013. I'll post this link, and it, as of this moment, only contains the 2 we mentioned, which are the shifting and the block hash refactoring.
I don't know if there's been a discussion about Skinny Create 2. I think there at some point should be a discussion about that. Unfortunately, Vitalik hasn't been present to champion it for a couple of weeks.
This came up on meeting 37, so about 6 weeks ago. Vitalik was there at that point to talk about it. Just reviewing the notes here, we left it off by saying, yeah, this is a good thing. It would make it easier to do counterfactual state channels, as you mentioned, and there's no EIP for it yet. Let's create one and discuss. I'm not sure if one has been created yet. If anyone...
Oh, it was. Yeah, he
okay.
created one, I think, the same day or the day after. So
yes.
There is a need. I don't think it has ever been discussed after actually becoming an EIP.
Right.
But it will be good. So I don't know, maybe it's not possible to discuss it today. But it would be good if the people who are in this call look into it. I personally like it.
Okay, so I guess we'll table this as well and bring it up again maybe when Vitalik or someone else can speak to that particular EIP. Are there any final thoughts on hard fork timing? Just sort of not the specific question of what to include, but sort of time frame. Short term, medium term, weeks, months, sometime this year, or do we really not really have any consensus at this moment?
Yeah, I think personally we should have a hard fork this year. In autumn, maybe.
Danny, is there any sense for when we're going to need a fork to include stuff for sort of FFG?
Not at this moment. We need to get a few more clients kind of running together. Before we have a test net with multiple clients running, I'm not going to put a date on that. I think that the other hard fork should be considered outside of it.
Yep. Okay. Makes sense. Okay. All right. So the last item on the agenda today is a comment here posted by Peter. I'll share the link about blockchain rent in the context of test network spam. I think Peter's not on the call. Does anybody want to speak to this or speak about this? I'll just briefly summarize here. Usually chain rent is brought up in the context of the mainnet, where we debate whether contracts, etc., CryptoKitties should be allowed to pose large storage overhead on full nodes. But he's making the point here that this is an issue on test nets. On Rinkeby, there are many contracts with over 10 megabytes of data, at least one instance of over 82 megabytes of compressed storage. It poses enormous overheads and synchronization, limits the usefulness of test networks for the entire ecosystem. Is there any possible solution, maybe a limited form of chain rent or other limitations on contract storage that might help keep these abuses more manageable? Any thoughts?
So if you introduce a limitation to storage usage for one contract, what prevents users from creating multiple contracts? They use different storage.
Yeah, so that would be something that needs to be addressed by a schema that has blockchain rent. I mean, yeah, that's a problem that needs to be solved. So how do we exact rent from which contracts at what time? And there are a couple of different proposals for storage rent and contract rent that I've seen over time. But is there anyone here who has who knows about the proposal that they kind of endorse or like?
So I've talked a lot with Phil Dian about the rent topic, and the way that he and I from him think about it is sort of the latest model being that you set some gas amount, some cost per time unit for keeping the data in state. And then every user who makes a transaction to this contract would pay to top up the contract's lifetime to 5 years. So when you deploy a contract, you get 5 years, and then any user who interacts with the contract pays to top it up to 5 years again. So if a contract is used a lot, you would just pay a super small micro fee to top it up, like an hour or a day or something. If a contract is very rarely used, then it costs more to interact with it. And if no one uses it in 5 days, it gets removed from state. And then if someone wants to reinstate it, it would cost that 5-year fee again. And I think that's a reasonable model and puts pretty low overhead on the users. The only real effect would be that things cost a little bit more.
Yeah. So, but it sounds like there will also be one more consensus critical data set to maintain for the client developers, right? Yeah.
So whether or not something is in state would be consensus critical, because what you're actually paying in gas will depend on whether or not what that state is. I'm not sure if it's adding all that much. I mean, it's definitely another factor, but it feels to me. I mean, you would obviously not base it on actual time. You'd base it on number of blocks. So I'm not sure. Yeah, I mean, I haven't looked at this into enough detail, on an implementation level, to say how easy or hard this is or what it introduces. But sure, you'd now have to agree that whether or not something is in state or not as well.
Yeah, I mean, if it would be really nice if you guys could write this down, and maybe we could try it on a testnet.
Yeah, do you think Phil would be interested in writing an EIP or at least a limited spec?
I think definitely he'd be interested, but I'd have to ask him.
Stateless clients would also solve this problem and might be easier to implement versus storage rent.
So Phil would argue that it doesn't solve the problem, and you're just moving the cost to the witness and sort of moving the cost of bandwidth and the witness generation procedure. That data still has to be somewhere.
Sure.
Yeah, storage rent would give us a way to eventually forget old parts of the blockchain, which would be convenient for all sorts of reasons.
But stateless clients also enable you to forget old parts of the blockchain.
I mean, unless you go and call into a contract that's, super old, then suddenly you have to re-remember it. So.
Yeah, but at that point, it's the user's problem, not the client's problem.
Cool. You mean with stateless clients, the user would have to supply the account data of the contract they're trying to call into?
Yes.
And that's also interesting. That is kind of like storage rent, but where you pay the storage rent yourself by storing the contract you're interested in, then people can prove that it was the correct one. But then the other problem with that is people still have to maintain old implementations of EVM instead of allowing us to eventually forget those.
Yeah, I think of stateless clients as very similar to storage rent with, what do they call it, reincarnation, but without all the complexities of the rent part. I mean, all the rent part becomes second layer.
The problem I would still have with it is my goal would be to be able to evolve the EVM over time better, and the only way to do that is to make it so it's impossible to execute old contracts. Well, the only way to do that without, you know, some sort of irregular state update. I mean, you would still require an irregular state update, but.
Cool. Yeah, so obviously rent is an important topic. I know there's been a number of sort of proposals related to this topic on the ETH Research Forum. It sounds great. If Phil or someone else would like to kind of turn this into an AIP, it would be interesting to bring this up on a future call. I think that's everything for the agenda today. So thank you guys so much for your time.
Hello.
Thanks, guys.
Yeah. Sorry,
Thanks,
Greg.
everyone.
Greg, did you have?
Hello.
Yeah, Greg, I can hear you. Did you have a comment?
Yeah, I totally lost connection just at the end of the Ewasm discussion. Casey started into something and then it went blank. So if someone could summarize like the very end, that would help. Probably Casey knows if any conclusion was reached. I don't know what it was.
The last thing on the topic I remember saying is that my concern isn't so much designing the most bomb-proof virtual machine in history, but determining what's the easiest way to enable users to deploy their own precompiles.
Which requires a reasonably bomb-proof system.
Right, so just reasonably bomb-proof, but not maximum bomb-proof.
Yeah, we can't make it perfect, but we can make it good and be prepared to deal with DOSs when they happen. But there's no point going in knowing that we're wide open.
Agreed.
Okay, thanks.
Thank you very much, everybody. As far as timing for the next call goes, I'm not aware of any conflicts in 2 weeks. So it looks like the next date will be June 15th. You know, speak up now or post on the GitHub issue if there's any conflicts that I'm not aware of.
Mm-hmm.
Thank you, everybody. Thank you very much, everybody. Have a great day.
Thank you. You too.
Thank you. Bye.
Thank you.
Bye-bye.